Well, hello Internet, and welcome to part 16 of my C++ video tutorial. In this part of the tutorial, we're going to talk about threads, time, protecting shared resources, and then we will create some examples in the differences between calculating primes with and without threads. Like always, all the code is available in the description underneath the video, and if you haven't watched any of the previous parts, you most definitely should, otherwise you will be confused, and I have a lot to do, so let's get into it. Alright, so here we are again, and you can see here a list of all of the potential libraries we may or may not use in this tutorial. So make sure you have all those and everything will be safe. The very first thing I want to do here is I want to create a function that is going to generate a random value based off of a maximum value that is passed to it. We're going to use this in a couple examples. So I'm just going to come in here and go srand, and we're going to use time once again, in milliseconds, to generate a sort of random value, and then we will return said value by going rand and then modulus on whatever the max is. And of course, the way modulus works is it's impossible to get a value that is bigger than whatever this max is whenever we use it like this. Alright, so if first off, I'm gonna show you a little bit about threads, and we're gonna ramp it up until we get more and more complicated, and then I'm also gonna show you some neat things we can do with time inside of C++. So this is going to be called execute thread, and it is going to be passed an ID just to represent the different threads we're gonna create. Now, if I want to get the current time, let's just call it now time, all I need to do is go standard and chrono and system and then underscore clock and then now. And that is going to give me the current time in milliseconds. All right, so now that I have that, what I need to do is convert to a time that we can output. So I'm going to go time underscore t, and I'm going to call this sleep time. And then let's go down to the next line, and we can once again go chrono system underscore clock and then to time underscore t, and then we're going to pass now time into that guy right there. Then we need to convert to our current time zone because it's not going to make sense otherwise. So I'm going to call this my local time, and then we go and put a star inside of there and local time, and then we pass sleep time inside of there. So we're going to be using this to make our threads go to sleep for certain periods of time. Okay, so useful stuff. Now what I'd like to do is print some information out on our screen. So we'll go thread, and then we'll print out whatever ID we assign to that thread. And then we will assign a sleep time. Let's put a space inside of there, so sleep time. And then we can go and output the time that we put our thread to sleep just by passing our sleep time inside of there. And then we'll throw in a new line, of course. Alright, now you're going to be able to also get a lot of information about time in general inside of C++, and I went and created these ahead of time so you don't have to watch me type them. You can see right here exactly how we can get our month, our day, our year, our hours, minutes, and seconds just by using these little shortcuts that we have right there. You can pause your screen, of course, at any time if I'm going a little bit too quick. And now what I want to do is go and actually put our thread to sleep. Now, I didn't explain this, but basically, a thread is just a block of code that executes. Now, for example, we've been using threads for forever. Main is a thread. This is just the main thread. It's a block of code that executes. Now, whenever you are working with multiple threads, that means that you are working with a multi-threaded application. Okay, so it's quite simple. And what's great about threads is that you will actually be able to utilize your processor to actually execute different blocks of code at the same time to sometimes get better calculations quicker and so forth and so on, as you will see as this tutorial continues. Well, what I want to do right now is put my thread to sleep, and that just means that it's going to stop executing for a certain period of time. So to do that, you just go this thread sleep and then 4, and then you go standard chrono seconds And then what I'm going to do is I'm going to use our get random function to have it sleep up to 3 seconds. So it's going to be somewhere up to 3 seconds, not more, no less. Then what I'm going to do is I'm going to get my now time. And once again, standard chrono system clock and now, and reassign that again. Get my sleep time once again. And I can just go and get this guy right here and copy it so I don't have to waste time typing. And then I'm going to grab this guy up here again and copy this so that we can see the difference in the time of the thread from the time that it awoke and then fell back asleep. Now I'm going to change this to awake time, and everything else can be exactly the same as it was. Okay, we can save that. And then I can come down here and create the thread inside of main. And to do that, we just go standard and thread, and let's just call it th1. And then if you want to actually call this function, so execute thread, and pass it an ID, how you do that is you just come up here and you go execute thread, which is the function that you want to execute, and 1 is going to be the ID that I pass inside of it. And then I can go and copy this and do it again for another thread, and we can just change the ID to that to 2. And then on top of that, what you need to do is join the thread to the main thread, meaning that main waits for this thread to stop executing before continuing execution of code in main. So we can go th1 and join, and then we're going to do exactly the same thing for the other one. So there we go, and just change this to th2, of course, and change this to th2 also. All right, and we can go and save that and run it. And you can see right there that there was absolutely no sleep time between these different parts. Let's run it again. And there it is, 6 seconds, 6 seconds, 6 seconds. So they basically executed at exactly the same time. Let's run it again. And there you can see that it actually did take some time though. And you can see right there that the random number of seconds, meaning that this thread was asleep for 2 seconds and this thread here was asleep for just 1 second. Okay, so just a brief overview of how you can create threads, how you can get a lot of information time-wise, and then how you can put threads to sleep and then have them come back awake. Now what I want to do is show you how you could create a pool of threads and then have them access the same piece of information. And what we're going to do is sort of simulate a bank account. I'm going to need another function here, and I'm going to call this get time, and it's just going to make getting the current time a little bit easier. So I'm going to go auto, and there's no really point of typing that out again because I already did this once before. So let's just paste that inside of there just to keep you from wasting your time. All right, so that's what it's going to do. It's going to return our time to us, just as I explained in the previous example. And then I'm also going to have a global here, and this is going to be our account balance for our fake checking account or whatever you want to call it. Then we are also going to use this mutex, and what it's going to do is protect shared data from being accessed at the same time. So it's going to protect the threads from accessing the account balance at exactly the same time and pulling money out of it. So we're going to call that account lock, and you're going to see how that works. And then we're going to actually create the function that is going to be accessing that account balance, and we're going to get an ID as well as a withdrawal amount from the account. And then the exception safe way for us to block our balance from being accessed by more than one thread at a time is to use this guy right here, and I'm going to go lock and account lock. And basically, it is going to restrict access to the entire scope of this function once one of the other threads comes in here and tries to execute this code. You would also be able to come in and do account lock and then lock specifically, and then followed by account lock and unlock, and then wrap your code inside here. So the code that you would want to be safe would be right inside of, right between lock and unlock. But that in some situations is not safe for if an exception would occur during your code execution. Sometimes you're going to use it, sometimes you will not. Okay, so there's 2 different ways to lock down your code. Then I'm going to come in and I'm going to go this thread and sleep, just like we did before, 4. And here I'm just going to go standard, chrono, and seconds. I could use get random, but I'm just going to change this to 3 seconds just so you can see the execution taking place on the right side of the screen. And this is this thread. And then let's print out some information about the actual money being withdrawn from our account. So I'm going to say whatever the ID is, or the ID is for the person accessing this. And I'll say withdraw and the amount of money that they want to withdraw from the account, which is going to be the withdrawal amount that they passed inside of here. And then I can print out some information on exactly when they tried to pull that information or that money out of the account. And I'll call get time to get that information. And of course, a new line. Then, of course, I'm going to have to verify that we have any money in the account. So I'll say account balance minus withdrawal is greater than or equal to 0. Well, in that situation, I can say account balance and take the withdrawal amount out of it, out of our account. And then let's just print out some information on the new account balance. So we'll say new account balance is, and then print out whatever that is. All right, so we'll be able to sit here and actually watch the account balance go up and down based off of the different threads trying to access and retrieve money out of our account. Else, if they're trying to withdraw money that is not available inside of our account, we're just going to print out a message that says not enough money in account, and we don't need to print out whatever the amount is inside of there. Just keep it nice and simple. Oh, what the heck, let's go and print it out. So we can just go like this and say current balance is and account balance, and then print that out. All right, so we have that all set up. Now we can go down inside of main and actually execute this by creating some thread pools. So what we're going to do, just good to understand that whenever we create these threads, that they are going to access the account randomly. So there's no definite way that they, the first thread's going to access the account, then the second, and so forth and so on. So don't expect that. So we'll go and actually create our thread pool. And then let's load our threads that we create into our array that we have here, our array of threads. And then what they're all going to be doing, which is accessing the function called getMoney, and it's going to pass an ID. And then they're all going to try to take out $15 out of our account. All right, so that created those threads. And then we need to, of course, join them to our main function that we have here, our main thread, however you want to call it. And to do that, you just take this guy right here and follow that up with join. And there you go. And now we can execute it. Let's move this over. And there we go. Whoops, there was an error. I forgot to put an equal sign inside of there. No big deal. Save it, run it. And there you're going to see execution taking place. Remember, there's a 3-second pause. So 2 tries to withdraw $15, and there's all that information. New account balance 85. 1 tries to withdraw $15, and you can see that they are going in there and accessing the account, and they will continue accessing the account every 3 seconds until we reach a point in which we have no more money in the account, see not enough money in the account, and then they are no longer going to be able to access said account. All right, so there is how we can go and block our threads and create thread pools and have everything sort of simulate a real world transaction. And now I'm going to cover how we can calculate prime numbers with as well as without threads. First, I'm going to cover how to calculate primes without threads, and then we can see the performance differences. So we can come in, and I'm going to call this find primes, and we're going to be using unsigned ints in this situation. So we're going to have a starting value, and then we are going to have an ending value as well. So another unsigned int, which is going to be the end. And then we can also have a vector where we are going to store this information inside of. So vector, this is also going to be an unsigned int and vector. So we'll be able to pass the vector inside of there to use it. Then what we're going to do here is just cycle through numbers while ignoring even values, because an even value, of course, cannot be a prime. So I'm just going to go unsigned int x is equal to whatever starting value they want me to start checking for. And we're going to continue checking as long as x is less than or equal to the endpoint. The x here is going to just jump over any even values, of course. And then once again, unsigned int. Yes, I know there is neater ways to calculate primes. I will cover those eventually. I just wanted to keep this nice and simple. So I'm just going to cycle through all of these different values, increment the value of y. Then I'm going to say if, and let's throw another one of those in there, if modulus y is equal to 0. Well, we know in that situation that we do not have a prime value. Else, if y plus 1 is equal to x, in that situation, we have a prime value. So we're going to go and push it onto our vector, and there we go. All right, so just wanted to keep this nice and simple, and that's how we are going to find out if a value is prime or not, and then we are going to push it on the vector or not push it onto the vector. Okay, so we got that. Now I can go and create said vector that we've been talking about. And again, this is going to be an unsigned int. And we can go prime, call it prime vect. I'm also going to check how long it takes for us to check these different values. So I'm going to go and get our time. And then I'm going to say find primes. And let's say I want to go from 1 to 100,000, and then I'm going to, of course, pass in our vector that we want to add those values to. Then after I do that, of course, I can come in here and actually print out all of those values. So I'm going to prime vect once again so that we can see all of them print out on the screen, and we can do a new line. And then I'm going to also come in and get our end time, and just by calling clock. And then I can print out some information in regards to how long it took for us to find all the prime values in 100,000. So print that out, call this execution time. And to get the execution time, we just go end time minus start time. But then we're going to have to divide by clocks per tick. And that's just the number of representations that number of clock ticks that make up each second. If we want to find out how many seconds have gone by, so we just go clocks per second, and then end this and clean the buffer. All right, so there we go. And everything else is exactly the same, and we can run this and test out how long it's going to take to find all the primes in up to 100,000. And there you can go. And then we can write down our time. You can see all the primes flying through. So that was 2 seconds and whatever, so many milliseconds. So we can remember that. I'll actually write that down. So that's going to be 2.12. And then we're going to use threads, and then we're going to see which are faster. So to use threads, what am I going to have to change? Well, I actually don't even need these guys. So let's just get rid of that altogether. Well, one thing I want to do, of course, I want to protect accessing our vector by more than one thread at a time. So I'm going to need that guy. Another thing I'm going to do just to keep this simple is I'm going to create a global vector here. So unsigned int, and have that be prime vect. And there we go. Got that set up. Then I can just go and get rid of passing the vector inside of here. So let's get rid of that. I'm, however, going to try to keep everything roughly the same, because if I go and change a whole bunch of different things, then, you know, the amount of time that we're calculating isn't going to make that big of a difference, or, you know, we're not going to be able to properly compare two things to each other. So for this guy right here, everything is going to remain exactly the same. I don't believe absolutely any of these different things are going to change, actually. So the only thing that most definitely is going to, well, this is going to be called prime vect. So prime vect, and there's that. And then I am going to use lock and unlock in this situation. So vector lock and lock. And then we're going to do the same thing for unlock. And that's, of course, going to keep people from accessing the vector, multiple threads accessing the vector at the same time. Okay, so we got that all set up. I'm then going to use another function. I'm going to kind of keep this, what's going on inside of main here. I'm just going to put it right here. So I'm going to call this void find primes with threads. And this is going to be passed an unsigned int. If anything, this is going to sort of maybe slow down the thread It's just talking milliseconds, but that's not going to make big changes in our final results. And let's see what else we can put inside of here. I'm going to go unsigned int, and I need a way to create these actual threads. So, there's really no way around it. And that is really going to be the differences between having one thread and having multiple threads, because of course there is going to be some machine time that is going to have to be devoted to actually creating threads. And in the other, whenever you only have one thread, of course, you don't have to devote time to creating each of those threads. There's an overhead to using threads. So whenever you're working on very small numbers, having multiple threads makes absolutely no sense. But whenever you have very, very, very large numbers, as you're going to see, it does actually impact the results. Even for 100,000, you're going to see that there are indeed, there is a difference between using threads and not using threads. So what I'm going to do here is I'm going to divide up the calculations so that each of the threads is going to operate on a different block of primes. I'm going to call that thread spread, and that's just going to be equal to whatever the end is divided by the number of threads. And then once again, unsigned int, new end, we're going to change start plus whatever the thread spread is. So let's say I'm only working with 10 values and I create 5 threads to calculate that. The first thread's going to handle 1 and 2. The next thread's going to handle 3 and 4. The next one's 5 and 6. I think you get it. So that's what I'm doing here. Thread spread. And that's going to be -1, however. And what else are we going to do? Well, I need to create my prime list for each of my threads. So I'm going to say for unsigned int x is going to be equal to 0 and x less than and the number of threads. And you can see there's definitely some overhead in working with threads, creating threads, of course. And then I'm going to call find primes, and then of course I'm going to pass in whatever the start is as well as the ending from where we are executing. And then after that, I have to change our starting time. So we'll go thread spread once again, and new end, and increase the ending once again. So thread spread. All right, and then we have that all set up, and then I need to join all of our different threads together. So I'm gonna go for and auto once again, and let's just call the thread T. And that's going to be thread vect and t join. So we're creating a thread pool once again to operate on creating these calculations. And then down inside of here, I'm just going to get rid of all this stuff because I already created a lot of it inside of this function right here. And of course, I need to monitor the amount of time that went by. Otherwise, it would be kind of worthless. And then I can call find primes with thread, and I'm going to start at 1 just like I did with the previous example. Then I'm going to go up to 100,000, and then I am going to use what I discovered on my machine is the optimum number of threads, which is going to be 3. Might be different on different computers. I'm then going to come in and get our end time so that we can see the difference. And then I can, of course, print out all of my threads just like we did previously. So auto I by accessing our vector where we stored all of our threads. And there goes that guy. And then, of course, we don't want to forget, we want to print out the amount of time that it took to execute our threads. And then we can compare that between using one thread and multiple threads. So I'm going to go end time minus start time, exactly like we did before, and double and clocks per second, and then endl. All right, and we have return inside of there. Find primes. Oh, this is going to be primes with threads, right? Find primes with threads. Yep, looks good. As long as I didn't mess up, everything should be fine. So we can see right here our execution time is 2.128, and we can run this, and there it goes. And here, using multiple threads, or using 3 threads to be exact, we were able to pretty dramatically, even with a very, very small data set, cut down our time by about 1 second, a little bit less than 1 second. All right, so there you go, guys. There are multiple different examples of different ways you can use threads. You can go in here and look at the different results depending upon increasing or decreasing the number of threads that we have inside of here. I can just go and use 1 thread right now, just change it to that, and 1.46 is what we had previously. And you can see there we used 1 thread and it took a considerable amount more. All right, so hopefully you found this tutorial useful. And like always, please leave your questions and comments below. Otherwise, till next time.